Routing and Remote Access, Part 5. I don't think I've ever taught one topic so many times in sequence here. We're talking about routing and remote access, and this is Part 5, and it's the final part of routing and remote access. Now, when we talk about routing and remote access, it's a huge topic, and we started part of the discussion in the last nugget about dynamic routing protocols, which itself is a pretty big topic. And we talked about routing information protocol. In this nugget, we're going to expand it into Open Shortest Path First, or OSPF, and that's going to be used for larger networks. You can also take a look at preference levels so you can determine, regardless of the metric, which kind of a routing method you want to use, whether it's local routes or whether it's OSPF or RIP. And we'll take a look at a comparison of RIP and OSPF, as well as looking at internet connection sharing. Now, this is something you can do on Windows 98 machines or Windows XP computers, but we can also do it on Windows Server 2003. But we'll take a look at the advantages compared to network address translation and firewall services within routing and remote access. Now, if your network gets much larger than 15 hops, then you're going to need to go to a different routing protocol, and that would be OSPF. And many people would actually even choose OSPF before it gets close to 15 hops, because OSPF is clearly a superior routing protocol in its intelligence and algorithms. So what you could do to add OSPF is very similar to what you did for RIP. Just right-click here, choose New Routing Protocol, and choose Open Shortest Path First. Having done that now, then we go down to this OSPF item, and we choose to, again, add a new interface, and we choose which network we want to be able to use. And then, of course, we have to specify that this is, an OSPF is available for this particular address. If there's multiple addresses on the same interface, then we can choose from a drop-down list. And then with OSPF, you're going to work with areas. And this is how OSPF will break up the announcements that it makes to the other routers. You can break up into multiple areas. And that way, the OSPF routers are only going to communicate really directly with other OSPF routers within the same area. If there are multiple routers on that connect to the same segment, you can establish a router priority as well, because two routers on the same segment will attempt to both become the primary router. Or actually, it's called the designated router, I guess. In any case, whichever one in this case has the highest number will become the designated router. And then in terms of the hop count and cost and the metrics, then you can specify that number here, which we've already discussed. This is also just a plain text password that, although it's masked here, gets transmitted in the clear over the wire. This is not really used with OSPF, not really used for security so much as it is for identification. And that way it can identify and communicate with other OSPF routers that also have the same password. And then you can determine what kind of network it is, broadcast, such as Ethernet, token ring, network that supports broadcast frames that will be able to communicate with a single frame and broadcast that single frame to all points on that same network. And then you can also use point-to-point, which would be something like a T1 or an E1 connection on both ends of maybe a WAN connection, that kind of thing. And then non-broadcast multiple access, which would be something more like an X25 connection. So OSPF is really quite an excellent protocol to use for routing, but we also need to consider the differences and the advantages and disadvantages between using RIP or OSPF. That's probably not a good idea to have both OSPF and RIP on the network in most cases. However, should it happen and should you need to work with both of them, right-click on General here and go to Properties. And just so that you're aware of it, I don't think you'll want to change this, but just be aware that there are preference levels so that you can identify which one of these will have a higher priority. For example, maybe you're primarily on a RIP version 2 network and you're just starting to migrate some things over to OSPF with new networking equipment and so forth. Well, if that's the case, then you might move the RIP version 2 Internet Protocol rank down. The lower the number, the higher priority it has. So I might move that down by clicking until it gets below 110, and then now it's got priority over OSPF. Once I start to get more routers that are all OSPF, and I get a priority there, then I might start to change that order. So then I'd move OSPF down until it had priority over RIP version 2. So just be aware of the fact that this interface is here, and you can manipulate that. Now let's go ahead and take a look at a comparison of RIP and OSPF, just to kind of summarize all of this and kind of cement this in your head. These are some just basic facts about each one of the routing protocols that almost pretty much correlate directly across one to the other. First of all, what's the advantage of RIP? Well, it's easy. You install it, and you can't just walk away from it as soon as you've installed it. It only works good for medium networks, though, up to medium networks. In fact, even in medium networks, a lot of times you'll still go to OSPF. But it does work at least in small to medium-sized networks, and that's because, primarily, it's limited to only 15 hops. You see, it can only count up to 15. And for each hop away that it has to consider for a destination router, it adds an additional metric to each hop that it sees there, and it can only count up to 15. So you can't go too far away with RIP in terms of your overall routing area. And then we also understood that it is a chatty protocol. I mean, it broadcasts all the time, every 30 seconds by default. You can change that if you want. But it is still chatty by default, and it broadcasts the entire routing table to its neighbors and to anybody else that will listen to it. Also, there's a convergence issue there because as the router network gets larger, then every 30 seconds, maybe they made a change in the network. Well, 30 seconds later, it advertises that to whoever's within its broadcasting range, and then whoever receives that 30 seconds later will broadcast all the changes that it knows about now to its broadcasting range. And it can take several minutes all the way around a network until you finally have convergence, which is where all of the routers agree on the routing table. Now, until you come into total convergence, when you make a change to the network, it is possible that you make a change that will directly create a routing loop. And a routing loop is something like this. Here I've got router A, here I've got router B, and here I've got router C. Router A is trying to get to router C, and the routing loop would say the best way to get to router C is to go to B, and then then B will take you to router C. But B says the best way to get to router C is to go to A. So I got these two pointing at each other for destined networks to go to router C, and what's going to happen here is they're going to get in a routing loop, and they'll just go about round and round and round and round and round, and no traffic's ever going to get to router C. And that's what a routing loop is, and that's a very simple kind of a routing loop. They can get to be a whole ball of wax in terms of the complexity and the difficulty in untangling that ball of wax. And then the other thing with RIP is it only considers hop count. I mean, maybe again I've got, A, B, and C over here. Well, it looks at the router between A and B, and it sees one hop here. It sees the difference between B and C, and it sees one hop there. So it thinks that it's better to go to a certain network by going to B first because it's only got one hop. However, maybe this hop is taking place over a 56K link of some kind. However, my A to C connection is a T1 line, so even though its metric is a total of 2, because there's one here for a total of 2, even though the metric is 2, it's a much better route to go. Well, RIP isn't going to see that on its own. You'd have to make static entries for it to be able to do that. Now, the other thing here, and I didn't really put it in the bullets here, but just as a general note, RIP has a way of telling the same story over and over and over again. I mean, even if there's not been a change to the routing table anywhere, it'll still broadcast that to its partners, still broadcast the entire routing table. It's like my dad, he passed away a few years ago. He's a great guy. But anyway, he was getting to be pretty old, and he grew up in the Depression and all of that. So he would tell me a story about when he was a boy. And, it was one of those, I used to walk 2 miles to school through 2 feet of snow, and it was uphill both ways and all that kind of stuff. He'd tell me this whole story, and then the next time I'd see him, he'd tell me the whole story again, and I'd nod my head politely and pretend like I'd never heard it before. Well, that's the way RIP is as well. It keeps telling the same story over and over again. However, don't let me get down on RIP too much, because again, for small networks, it's easy and it works, and you just let it fly and you're fine. And if you can survive the broadcast traffic, which might not be overwhelming depending on how much your network is used, go ahead and go with it. On the other hand, there's OSPF, which is a more complex routing protocol, but it's also just better. Sometimes when things are better, they're also more complex. It's best for large networks. There's not really even a limit to the number of hops or anything like that. I'm sure there's a theoretical limit, but in terms of the size of your network, you can't just say, once you get to, 500 hops or something, OSPF will just crash and burn. That's not really true at all. And in fact, there's also ways to make it more efficient, like I was talking to you earlier about the areas and stuff. You can kind of break up your OSPF areas into different areas so that you can limit the amount of traffic that goes on for router announcements. And you can do the same thing there also with something called a backbone area, which will use area border routers. And that helps to cut down on the amount of traffic also that takes place. And then there's no loops in OSPF. There just isn't. There's a pretty fancy algorithm that goes on with OSPF that it uses to calculate its routing configuration. And it's very well able to predict where a loop might occur and to avoid that situation. And it's also extremely fast convergence, even in just ginormous networks. So definitely OSPF would be the way to go. But ironically, if you're really in a large network, you're not going to use Microsoft routers anyway. You're going to be using real routers with OSPF. Now, let's not also forget that OSPF is a better routing protocol because it converges faster, which I've already mentioned. But the part of the issue there is that what it sends out is more efficient. Instead of sending out the whole routing table or telling the whole story over and over again like my dad did, it'd be more like sending out just a summary statement. Like if I were to tell you, my lawyer said I'm going to be acquitted. Well, there's a whole story behind that, but I'm just giving you the latest update. And I'd tell you the whole story behind that, but my lawyer also said I shouldn't say anything else. One of the problems we have, especially in smaller environments, is how we allow our clients on the inside of the network on our LAN to access the public internet without giving them public IP addresses. In larger networks, we have more sophisticated hardware solutions where we'll have NAT translators of some kind that are integrated into some kind of a network device. But especially for those smaller offices, might be a little bit more of a challenge. Now, one thing you can do is to configure the interface to allow translation. So we could go to something like this public network that would connect to the internet, and we would have to have two network cards, of course. This one connects to the internet, and it's where we access the internet, and this one would connect to our private network. In any case, you'd go to the one that connects to the internet, and you choose Properties and go to Advanced, and here you'd simply select Internet Connection Sharing, which would then allow hosts with private IP addresses on the LAN to access the network through this interface. And what happens is there's a local address table here that will record the private IP address and correlate it with the randomly assigned port number. Then it will forward that request out to the internet using the public IP address, an internet-worthy IP address on this interface. And then when it gets an answer back, whether it's a web page retrieval or a GET command or something like that, when it gets that answer back, it will then use the local address table that it had constructed and determine who that's supposed to go to, who the answer is supposed to go to, because included in that, again, will be a designator for that random port number that we had selected. So it correlates that with the local address table. In any case, then it gets the answer back to the client, and the client pretty well transparently just accesses the internet as if they were connected directly, at least in terms of the user experience. Now, although this works pretty great for really small offices and even for home use, because you can have the same option on your Windows XP computer, maybe you can share a broadband connection that way, it's not really ideal for a lot of other purposes. Let me give you an example of why. If you go ahead and choose to use this item, then on the private network side of things here, then where your other clients are also connected, then they are going to request an IP address from this server. And the server, or Windows XP computer, again, whichever one it is, it's going to become a mini DHCP server with absolutely zero configuration that you can set up. And it sends out IP addresses in the 192.168 Class C address range. So the reason why that becomes an issue then is because if I also have servers on this network, and let's say I got a server at 192.168.0.2, and I've got several hosts on the network, well, you see that DHCP allocator that takes place here is going to just start to indiscriminately distribute addresses starting with the lowest number. It's going to issue 1, and then it's going to issue 2, and then I'm going to have an IP address conflict on the network because I already have a server with a .2 address on that network. Well, because of the limited configuration of ICS, the fact that you can't exclude addresses and you can't configure your own address range to hand out, you can run into problems with it like that. And in that case, you'd probably be better off to go to something like using network address translation in routing and remote access. So let me go ahead and make sure that that's turned off because we don't want to actually use that now. And instead, we're going to go to routing and remote access here, and that's going to allow us to use this capability instead. And here's how that works. See, one of the advantages by using network address translation as opposed to ICS is that I can choose whichever private IP address range I want. In fact, it doesn't even have to be a private. If for some strange reason I want to use public, I could do that as well. Because you specify whatever you want on this NAT server for the range in here, but maybe you want 10.9.8.0 for all these hosts within here. The other thing I can do is I can reserve public IP addresses assigned to me from my ISP, and I can designate them for special purpose. For example, here I got an ISP assigned address that I'm using for my internet router interface right here. So I'm going to use 66.224.47.1 for that interface card. Now I also have 66.224.47.2 And what I want to use that for is, I've resolved that through a host record on my ISP's DNS server to my web page. But my web page is actually on my private network over here. So what I can do with this then is I can allow people from the internet to resolve the name to my DNS server, then connect to this IP address, which in reality, when it goes into the NAT server will say, oh hey, that's a reserved IP address that's actually supposed to go to this www server down here. And that one is the IP address in my private network of 10.9.8.4, and so it'll be able to translate this address through their NAT server down to this web server and allow the network traffic to pass back and forth across the internet. Now, those of us who have worked with firewalls quite a lot look at this and maybe you kind of cringe a little bit because there are much more sophisticated solutions than this. Nevertheless, it's a Microsoft feature, so we should know about it, and we should know how to configure it. And I suppose it does have some usefulness, especially in smaller networks where they can't maybe afford a full-blown router from Cisco or some other network device that'll do this for us. Anyway, here we are at the Internet routing remote access item here, that is, and under IP routing for general, we don't see any network address translation item. Normally that's going to be installed by default, but I'm going to show you how to install it manually if you need to. Just right-click here and choose New Routing Protocol to choose the NAT Basic Firewall. You can also just make this a firewall only if you want, but we're going to use NAT for this function. And once we've done that, we get this node down here now where we'll have to add in both the public and the private interfaces. Now that I'm here, I want to go ahead and add in the interface. I'll right-click here, choose New Interface, and I'll specify the private network is connected to the private interface. I just double-click on it. It pops open this dialog box. Also, again, you can use inbound and outbound filters if necessary. So if you only want a certain kind of traffic to come in and out of this network, you can do that as well. I can also set this up as a basic firewall only. That's what I was mentioning earlier, where here I'll just click on basic firewall only, and at that point, I again specify which filters I want to use. But in our case, private interface to the private network. Then I'll go ahead and OK all of this, which there's not that much to it. I just click OK. And then I'll go ahead and click a new interface here for my public network. And this will be designated as the public interface connected to the internet. And then I'll enable network address translation on this interface. And then in addition to that, I can also enable a basic firewall on this interface, which is not a bad idea. That way, it's only going to accept data from the internet that was originated by the private network. So in other words, unsolicited attempts to access my network from the internet will be rejected. Then I can specify my address pool here as well. This will be where we have the reserved item. Remember I was talking about here where I have an address pool which will be any number of IP addresses from my ISP. So if I wanted to do that then, I would go into this and add in the starting address and the ending address along with a subnet mask. So perhaps, for example, I've only got 3 addresses from my ISP, and they've given me this subnet mask. By the way, this will calculate for you automatically. So if I were to do, 0 here, it would give me all through 1 through 255. But we'll just go ahead and enter in 252 because we only got 3 IP addresses from our ISP, which would not be uncommon in a small organization. So we'll click OK here, and now I've got this reservation. If I want, I can designate an IP address out of this range. So I'll click on Reservations and click on Add, and I'll say I'll reserve this public IP address. And I'll enter in the public IP address here, 66.224.47.2, and I want it to go to this specific computer on the private network. And then I would also, of course, have to allow incoming sessions to this address, which mean that would be unsolicited traffic that was not originated from the private network. And that's the purpose of this if it's going to be a web server or an FTP server or something like that. So then I'll go ahead and click OK there and OK, and now it's pretty much just going to allow that traffic to come through whether or not it's solicited from the inside. Now I can also do a similar thing over on services and ports. Maybe I get an FTP server, for example. I'll simply select that item, and then I'll just specify whether this FTP server is on this actual interface, or if there's an address pool entry I want to enter in. I'll just put in that IP address here as well, and then I'll put in the private IP address here also. So it's very similar in function to the way what we saw with the address pool and the reservation. Now once you've got all that configured, you can also then right-click on the NAT Basic Firewall here, go back down here to Properties, and then you can go up here to Address Assignment, and this is where you'll configure what you want the IP address range to be. So this is where I specify that I don't want 192.168.0. I want to use 10.9.8.0 with this subnet mask. And if I have some exclusions I want to enter in here, I can reserve IP addresses here as well that will not be sent out to DHCP clients. And that's where this has an advantage over something such as ICS, which might issue addresses in the lower end of a range to clients when they're already being used by various servers on my network. And then suddenly people can't get their email from the Exchange server because my Windows XP computer already has that IP address and get IP address conflicts and all that kind of stuff. So here's where you'll exclude those addresses that are already in use. And then up here for name resolution, I need to have a way of resolving DNS queries for my internal clients. So I'll just use the DNS server that's configured for this specific RAS server. And whatever DNS server I'm using here is also going to be used for those RAS clients. Also, if I want to, I can connect to the public network when a name needs to be resolved. And I'll have to have a domain dial interface. I don't have any right now because I deleted them. But if I had a domain dial interface that I needed, then I would allow that to happen as well. And that might be the case if I had a modem connection to an ISP or something like that. In this nugget, we looked at routing and remote access, and this was, thankfully, the last of 5 with routing and remote access. Now, it's not that routing and remote access is so bad, but it's a giant topic, and we saw that as we've gone all through the first 4 topics, where we concluded the last series with a discussion of routing information protocol for dynamic routing protocol. Here we went into OSPF, or Open Shortest Path First, as a superior routing protocol, especially for larger networks. And we also took a look at how you can configure preference levels so that you can determine whether you want local routes to be preference above a routing information protocol, or if you want that to be a preference above OSPF, and so forth. And the default settings, quite frankly, are usually pretty good for what you want there, but you can adjust them if you want. Now, we also looked at the difference between RIP and OSPF. Now, RIP is not always a rip-off. It's a pretty good routing protocol. It just depends on the context. In a small network, pretty easy to set up. Just let it run. But as you get larger, you need OSPF. Then we took a look at internet connection sharing, which we've had since like Windows 98, and it's also available in all client operating systems as well as Windows Server 2003 now. And you can use it to route private networks to the internet. But network address translation within routing and remote access services is a much better solution and gives you more flexibility. And we also took a look at that. Well, thank you so much for hanging with me with all of our RAS discussions. I hope this has been informative for you, and I'd like to thank you for viewing.